Hello, grade 12, how are you? Mr. Nulav is here again. Um, Today I want us to look at maximization or optimization. That is application of calculus. Those who have not watched the previous video, may you watch that one, and don't forget to subscribe. We have this question, which says a right circular cone with a radius p and height t is machine cut out. It means it was cut out by a machine from a solid sphere with center C with a radius of 15 centimeters as shown. Let me just open. So we were given the formula for sphere and also the formula for cone. That is the volume for sphere and also the volume for what? Cone. Now this is what they are talking about. We have a sphere. A sphere is like a ball, has a spherical shape. So this sphere, they use a machine to create a cone out from this sphere. So this is the cone, this one. And they said the height of the cone is T. It was said here. And the radius of the cone is P. So this is the radius of the cone. The radius of the cone is not the same as the radius of the sphere. The radius of the sphere is R. It was given to us as, let me show you here. The radius of the sphere is 15 centimeters. So this 15 centimeters, that's the radius of the sphere. The sphere is like a ball. The ball has a spherical shape. Okay, now the question is saying we should first, from the above information, this one, express the following. AC in terms of T. They want us to express AC, this AC, in terms of what? T. How are you going to do that? You know that T, which is the radius of the cone, is the same as the distance from here to here is 15. That is 15 plus AC. AC is the same as CA. So that gives you T. So they want us to express AC or make AC the subject of the formula. So you transpose that as plus 15. If you transpose, it's going to be minus 15. So AC is equal to T minus 15. Okay, now let's look at the next question. It says, express P squared in its simplest form in terms of T. So this one we are going to use Pythagoras Theorem. So here we know 15 squared is equal to P squared plus AC squared. Then we already know AC. Remember, we know AC to be T minus 15. So 15 squared is 225. P squared plus AC. Our AC is T minus 15. So we substitute T minus 15 here. We bring the squared. Then we need to expand it and make P the subject. So we are trying to expand. So to expand this one, we are going to get this. Let me bring it for you to see what we are talking about. Let's expand. T times T is going to give us T squared. T times minus 15 will give us minus 15T. Minus 15 times T is going to give us minus 15T. Minus 15 times minus 15 will give us plus 225. Then we can now minus 15 minus 15 will give us minus 30 plus 225. And if you continue to simplify, you want to make p squared the subject, because that is what the question is looking for. So here you need to transpose all of them. So plus 225, if you transpose, is going to be minus 225. Then plus t squared is going to be minus t squared. Then minus 30t is going to be plus 30t. Then when you continue, we are going to have 30t. This will blow off to be 0, then minus t squared. So we have expressed p squared in terms of t in its simplest form. Okay, then the next question says that show that the volume of the cone can be written in this form. Let's see how we are going to show. We were given in the formula that the volume of the cone is this one. It was given in the question. Then it was also given that r, the radius, is equal to p, and the height is equal to t. It was given also in the question. So here we are going to substitute. This is 1 over 3 pi. Instead of writing r, we are going to write what? P squared. Then instead of writing h, we are going to write t. But we know that 30t minus t squared is equal to p squared. The one we just calculated, the one we just found, this one. So this one, so in place of p squared, we are going to substitute this there. So here we still have our 1 over 3 pi. Instead of writing p squared, we are going to write 30t minus t squared, because p squared is equal to 30t minus t squared. So this will represent p squared, then our t. Then we are going to expand this one. If we expand this times 30t, will give us 30 over 3 pi t squared. Then the same thing multiplying, including the t, because this t is also multiplying. So you have t squared, then this t will multiply to be t to the power 3. Then we are going to have our pi. The pi over this must come. So we have this. So 30 divided by 3 is going to give us this one. Then we have our pi t squared. So we have proved it. Okay, then the last one, calculate the maximum value of t in which the volume of the cone will be maximum. So the information you have here, if you take the first derivative, so if you take the first derivative, you are going to have this one. Then you make it to be equal to 0. If you make it to be equal to 0, we can factorize this out. So it means pi t is equal to 0, and 20 minus t is also equal to 0. So it means t is equal to 0. When you make t also the subject, you are going to get t is equal to 20. And the last question says, what percentage of the sphere was used to obtain this cone maximum volume? So the first thing is we are going to use this. Substitute 20 into the formula. If you substitute 20 into the formula and you press on your calculator, you are going to get this. This is for the cone. Then you substitute the same 20 into the sphere. If you substitute into it, you are going to get this. So we are going to say the sphere, the value for sphere over that.